Hi, I'm Lindsey from the Department of Horticulture and Crop Science, and I'm really excited to be sharing some of our preliminary results from an experiment that we're doing trying to emulate ultra-early soil conditions and measuring how different factors are affecting soybean emergence. So we're set up the study to really try to quantify the impact on emergence and early season growth of soybeans as affected by initial soil moisture content at planting, the planting depth that we're utilizing, as well as how temperature and water added shortly after planting affect that emergence efficiency. So to do this, we set up a laboratory experiment using field soil, and we set up different trays where in some soils we had them be on the drier side of having a moisture content of 20% available water content, and we had some that were more on the wetter side, which were at 60% available water content. Within each tray, we then took soybeans and planted them at one of two depths, either 1 inch planting depth or 1.5 inch planting depths. And then we exposed them to different temperature and water treatments 1 hour after they had been planted and put into our different chambers. So just to demo this was kind of a similar tray to what we had used. Half the tray was planted to one depth, half the tray was planted to a second depth. 1.5 is usually the recommended planting depth for soybeans, but we were curious if planting shallower could help accelerate that soybean emergence, particularly under cold soil conditions. So each one of these flats was then treated to different temperature and water combinations. A few of the trays were put directly into a warm chamber. Warm is in quotations because in this case, our warm chamber was actually held at 50 degrees Fahrenheit. Some of those trays received no water, or they received a 1/2 inch equivalent of water added of that 50 degree temperature water. And then we let those sit in that chamber for 10 hours. Different trays were placed directly into what we called the cold chamber, which in this case was held at 35 degrees Fahrenheit, simulating what would happen if a cold front had gone through after planting and dropped the air temperatures substantially for a field that had been freshly planted. Similar to the warm chamber, we added water. We added either no water, 1/2 inch of rainfall equivalent of the 35 degree water, or we added a 1/2 inch water equivalent as ice, almost emulating like if a snowfall had come through and covered that soil. We also had then those cold chamber trays. We returned them back to the warm chamber after that 10-hour period, and some of them didn't get any additional water, but others received a 1/2 inch of rainfall after that initial 10-hour period of exposure to cold temperature. After 14 hours in the warm chamber at 50 degrees, we bumped the temperature up to 70 degrees and watched soybean germination and emergence happen over time. We saw that after all of this stressful experience for these soybeans, we saw a significant effect of the temperature and water treatments across planting depths and initial soil moisture contents. But then we also saw that the initial moisture content and planting depth impacted successful emergence as well. What we saw was that when we initially added water 1 hour after planting, regardless of if it was 50 degree water or 35 degree water, emergence was substantially reduced in our treatments. We saw that addition of ice or warm water after that initial 10-hour period marginally decreased emergence, but not as much as that initial hit of water, regardless of what the temperature was. Our best emergence occurred when no water was added in any of our treatments, even if those seeds were exposed to really low temperatures during that first 10-hour period after planting. The interaction of initial soil moisture content and planting depth was also really interesting in that our deeper planted seeds, regardless of the initial soil water content, tended to emerge better than our shallow planted seeds, which would suggest maybe pushing planting depth a little bit deeper early in the season may be beneficial to improve emergence. So this preliminary work that we've been doing suggests that rainfall shortly after planting, particularly in that initial 10-hour period, was more damaging than if snow had fallen or if no precipitation had fallen. When we had low temperatures but no precipitation, emergence was similar as compared to if the soil stayed at 50 degrees Fahrenheit. And so initial water content shortly after planting could be the most damaging factor that we're seeing with regards to early season planting and emergence success. But again, this is a lab study and we need to continue this work in the field to verify what we're seeing. We also observed that deeper planting had slightly better emergence, particularly when soils were initially drier, as compared to planting on the shallower side. So early planting conditions, sticking with that 1.5 inch planting depth may be an advisable practice, but there could be some other considerations with regards to susceptibility to crusting and other issues that need to be considered there.